Hi everyone, so in this video I want to talk about how we can take a graph and then transform it into this other graph by altering its equation. Okay, so the one that I want to talk about in particular today is not the orange or the blue graph, but I want to talk about how to turn the black one, so the black one will be our original function f of x, into the new red one. Okay, maybe I'll just call the red one g. Okay, actually let's not name it because sometimes that throws people off, but that's the target. Okay, so the first thing I like to do when I see these problems is just write out what transformations we see. So what transformations do we see? Okay, and I don't care about the order yet. So let's see. Well, the way I kind of look at this is I kind of find a reference point, or maybe a couple, on the original parent graph and then see what happens to those points. So let's mark off the little vertex of this parabola portion if a green point, and in blue I'm going to mark off the I don't know what this point will be called, but where that parabola meets that linear portion. Okay, we can kind of see here in both cases both points have gone up 3 units, plus 3 plus 3. So I can see there's a vertical shift of plus 3. Okay, cool. What else do we see? I think we can also see here that if I look at the kind of the mirror image or the symmetric point of that blue point, if we can see here at first, it's those 2 points are 2 units apart. But on the red graph now, they are suddenly only 1 unit apart. And so that tells us we have a horizontal stretch. I say stretch even though it is getting squished or smooshed. We have a horizontal stretch by a factor of 1/2. So when I say the stretch factor, that's how far it's being stretched or compressed. If I'm stretching it 1/2 as wide, you're really smushing it to half its size. And so now the last one here is, and this is the weird one, which doesn't seem too weird, but I'll draw it in yellow. Oh, let's do purple. We notice that the graph is shifted a little bit, but it kind of depends on where you're looking, because the green point, it only moves over half a unit. Okay, it moves over half a unit, but wait a minute. The other point, the blue one, and I'm talking about this blue one, so I guess now it's purple, it didn't move over at all. And so when you actually see this, what really happened was some kind of, this is indicative of some kind of stretch or compression, because some points move more than others, or some points move and some don't move at all. But the fact that this part did move when it started off on the x-axis, or sorry, on the y-axis, it does suggest a horizontal shift of some kind. Of -1/2. So -1/2 meaning it's going to the left 1/2. Okay. And so here's how I would suggest going about applying these transformations in terms of changing the equation. Okay, sorry, I had to kind of plan out a strategy for this. Now, one thing we could notice is that if you are combining a horizontal shift and a horizontal stretch or compression, it actually really matters what order you do them in. A horizontal stretch and a vertical shift actually don't affect each other, and here's kind of why. Remember that when you're stretching away or from the y-axis. So this is a horizontal stretch. So the center of your stretch is the y-axis. Away from the y-axis. And so here's what we can see. Like, let's apply the transformations in this order. Let's suppose I shift it once, then I stretch it, and then I shift it up. Okay, so a horizontal shift of -1/2. Well, let's see, a -1/2, so that's going to be move everything to the left 1/2. So this point's going to go right here, and I'm doing this in purple, right there. And so let's see, that's where that would go. Again, everything's just being shifted over 1/2, so I think this is going to look something like this. So that first step, that's my shift. Oops. Oopsies. That's my shift. Okay. Now I'm going to stretch it. But remember, your stretching happens relative to the y-axis. And so if this point right here is now at 1.5, this point right here, its x-coordinate is now 1.75. So let's see, 1.5. So that will be right around there. The vertex of this, so let's do this next step in yellow here, right there. The vertex of the parabola, since it was at -1/2, now it's going to be at -1/4, actually. So it's going to be right there. And the vertex over here, or sorry, that pointy part, that's at -1.5, so now it's at -1.75. Wait, that doesn't make sense. That's at -1.5, so it's at -0.75. There we go. -0.75, which would be right here. And so this graph now looks like this. And all of these points would be, would be brought back down here. So it's not going to have the same, that linear piece portion is not going to quite have the same slope. Okay. Now look, if I push this up 3, you can see now that, well, actually this graph is not 100% correct, because 1, 2, 3, oops, that should actually be up here, here, and here. So this graph now looks, and I'll draw it back again in purple. This graph is gonna go like that. Oops, right, so. Which is, again, not quite the red graph that we want. So what happened here is that you have to be aware of where the stretching happens. So let's erase this and kind of start back at the drawing board. Okay, so I've erased this. And now what we're going to do is we're going to shift the order here. Shift. We're going to rethink the order here. But notice, if you remember before, the vertical shift was not affected at all by the horizontal stretch, because if you shift it, its position along the x-axis has not changed, so that shift doesn't matter. So if we want, we could do the vertical shift first, and heck, why don't we do that? So we'll do that first, then let's stretch it, and then let's shift it. Okay, so let's do that. So the shift, of course, is going to just push everything up. So our new black one, I'll do that right here, is going to be at, I realize now that that was going to make it a little bit more difficult. So let's actually do the stretching first, then the horizontal shifting, and the vertical shifting. We'll still save it last. Okay. So the first part, the vertical shift, the horizontal stretch, which we'll do in blue, lets you stretch everything 1/2. So that just squishes everything inward. This goes right here. Since the vertex is already on the y-axis, it doesn't go anywhere. And this part is going to go right there. Again, cut every x-coordinate in half. Like so. Okay. So first off, now this piece looks, I guess, hard to see because I can't draw it perfectly, but it does look pretty correct compared to this one. And then let's see, this one is going, this point over here is going to go from 2 down this way. So it should look something like this. Like so, sorry, I was looking at the red one. I should have been looking at the black one as my starting point. Okay, so I've now at this point smushed it in half. Now let's shift it horizontally to the left, 1/2 unit. That, if we do it in green, well, that's just going to push it all right here, right here, right here. So sorry, it's going to look a little messy here. And normally you would do it on different graph, different sets of axes, which I should have done, and there's no reason really for this, so I apologize. And then now we're going to shift it up 3, and you notice this point is going to go right here. The vertex is going to go right here, and this point is going to go right there. Okay, so in a sense, it absolutely matters which order you do the transformations in. Essentially, the parts you have to be careful of is when you have a stretch and a shift that are in the same direction. So and by same direction, I mean horizontally or vertically. In this example, you had a horizontal stretch and a horizontal shift. If you do one before the other, the resulting graph is going to look very different. Which one is correct? That's really that depends on what the starting function is compared to the target function. So I can't really tell you to always do stretching first and then shifting, because it depends. Okay, but what is neat is that if you have a vertical shift and a horizontal stretch, that order doesn't matter because they don't affect each other. Okay, I'm gonna stop the video here just because it's kind of long, but I do want to talk about how to get the equation of this red graph now.